Welcome back, guys. In this teaching video, I'm looking at 3.6 approximating a binomial distribution. 3.6 represents chapter 3, section 6 of the Pearson A-level Maths Applied Maths Year 2 textbook. So I'm going to start off by going through the key facts for this particular section. We'll be taking a binomial distribution and we'll be applying a normal approximation to it in summary. Anyways, let's break this down. If we have a discrete distribution x, which follows a binomial distribution with fixed sample size n and fixed probability p, then we can approximate this distribution to be a continuous distribution y, which follows a normal distribution with mean mu and variance sigma squared. This approximation, ladies and gents, is only valid if two conditions are satisfied. Number one, if n is large, and number two, if p is close to 0.5, where the mean mu is given by np and the standard deviation sigma is given by square root of np multiplied by 1 minus p. Now, whenever we take a discrete distribution and we approximate it to a continuous distribution, we need to apply something called a continuity correction. Let's have a look at this example. The random variable x follows a binomial distribution with sample size 150 and fixed probability 0.45. Use a suitable approximation to estimate the probabilities given in part A, B, and C. Okay, so let's start off with part A. Firstly, we know that x follows a binomial distribution with sample size 150 and fixed probability 0.45. We're going to approximate this to a random variable y, which follows a normal distribution with mean mu and variance sigma squared. Now, to calculate the mean mu, we have to use the formula n multiplied by p. So mu is given by 150 multiplied by 0.45. So if I put this into my calculator, I get 67.5. Okay, so that there is the mean mu. How do we calculate the standard deviation sigma? Well, we apply this formula over here. Square root of n multiplied by p multiplied by 1 minus p in bracket. So sigma, the standard deviation, is given by the square root of n multiplied by p, which is 67.5. And we're going to multiply this by 1 minus my p-value, which is 0.45. So if I put this into my calculator, I get that the standard deviation sigma is equal to the square root of 37.125. What we're trying to calculate is the probability that x is less than or equal to 60. Since we're going from a discrete distribution to a continuous distribution, we must apply a continuity correction. So I'm going to explain how to apply a continuity correction with the use of a diagram. Okay, so I've got a block over here. The block represents 60. Since we have x equals 60, we're going to shade in the block so that 60 is included. X is also less than 60, so we shade in the left-hand side of 60. Now we find the lower bound and the upper bound of 60. So the lower bound is 59.5 and the upper bound is 60.5. So the shading actually starts at 60.5 and we go to the left. Hence the probability is approximately the probability of y being less than or equal to 60.5. Now this probability represents an area because y follows a normal distribution. Y equal to 60.5 is just a straight line. It contributes to 0 area. So if I was to exclude the 60.5, it will not affect my answer. But to be consistent with this diagram, we're going to include the 60.5. Now this probability can be rewritten as the probability of minus infinity being less than y, which is less than or equal to 60.5. I'm going to represent this on a bell-shaped curve. So here is my bell-shaped curve. The bell-shaped curve is centered at the mean mu, which is 67.5. Now 60.5 is on the left-hand side of 67.5, so it will be somewhere over here. That there is 60.5. So this probability over here represents the area to the left of 60.5. So if I was to shade it, it will be this shading over here. We're trying to calculate that area. What I can see is that the lower limit has to be a number far more smaller than 60.5. We can't put negative infinity into our calculator. So we can take minus 1000. The upper limit will be 60.5 and the mean mu will be 67.5. The standard deviation sigma will be square root of 37.125. Okay, so now I'm going to be using the normal CD function in my classwiz calculator in order to find this probability. So if I use my classwiz calculator, I get that this probability will equal 0.1253 to 4 decimal places. Okay, ladies and gents, let's move on to part B. Right, so we want to approximate this probability. We need to apply a continuity correction. Okay, so I'll start off with the block. This block over here represents 75. It does not say x is equal 75, so we do not shade in the block. We have that x is more than 75, so we shade in to the right of 75. So this is my shading. Now, once I've got my shading in, I can find the lower bound and the upper bound. The lower bound, ladies and gents, will be 74.5 and the upper bound would be 75.5. Okay, so this probability over here is approximately the probability that y is 75.5 or more. So y is greater than or equal to 75.5. Like I said before, y equals 75.5 contributes to 0 area. So if we were to exclude the 75.5, our probability answer will not change. But let's just be consistent with the shading over here. And let's write down y is greater than or equal to 75.5. Now this probability can be rewritten as the probability that 75.5 is less than or equal to y, which is less than positive infinity. Let's represent this area on a bell-shaped curve. So here is my bell-shaped curve. My bell-shaped curve is centered at the mean of 67.5. The 75.5 is on the right-hand side of 67.5, so it will be somewhere over here. Probability y is greater than or equal to 75.5. In other words, probability 75.5 is less than or equal to y, which is less than infinity, represents this area over here. We want to calculate this area. So what do we have? Well, firstly, we have that the lower limit is equal to 75.5. So lower limit is equal to 75.5. The upper limit will be a number far more greater than 75.5. We can take 1000. The mean mu is equal to 67.5. The standard deviation sigma is equal to the square root of 37.125. So now I'm going to use the normal CD function on my classwiz calculator in order to work out this probability. So if I use the normal CD function with these values, I get that this probability is equal to 0.0946 to 4 decimal places. Okay, so that there is the end of part B. Let's have a look at part C. Right, so this time we want to estimate the probability that x is more than or equal to 65 but less than or equal to 80. So we need to apply a continuity correction. I'm going to make use of a diagram. So what we have is two blocks. Here is my first block, 65, and here is my second block, 80. Now x is equal 65, so we shade in this block to include the 65. X is equal 80, so we shade in this block to include the 80. And we know that x is between 65 and 80, so we shade in the middle portion over here as well. Okay, so now we're going to find the lower and upper bound of 65. The lower bound, ladies and gents, is 64.5 and the upper bound is 65.5. The lower bound of 80 is now going to be, as you can see, 79.5 and the upper bound would be 80.5. So the shading actually starts, well, the complete shading starts from 64.5 and it ends at 80.5. So applying my continuity correction, we see that this probability is approximately the probability that y is more than or equal to 64.5, but is less than or equal to 80.5. Remember, this probability over here for y represents an area. Y follows a normal distribution. So the y equals 64.5 and the y equal 80.5 contributes to 0 area. We can actually exclude these two values. We can just write y is between 64.5 and 80.5. It will not change our answer, but we want to be consistent with our diagram. So if you were to include them, no problem at all. Okay, so let's represent this particular probability, or you could say this area, on a bell-shaped curve. Here is my bell-shaped curve. The bell-shaped curve, ladies and gents, is centered at the mean 67.5. The 80.5 is on the right-hand side, so it will be over here. And the 64.5 is on the left-hand side, it will be somewhere over here. So 64.5. Now what we want to do is calculate the area between these two numbers. And that area precisely is this probability. Over here we see that the lower limit is equal to 64.5. The upper limit is equal to 80.5. The mean mu is equal to 67.5 and the standard deviation sigma is the square root of 37.125. Now we're going to use the normal CD function in our class-based calculator with these values to calculate this probability. Okay, so this probability will equal 0.6723 to 4 decimal places. And ladies and gents, that completes part C of the example. So we've done A, B and C. We started off by taking the distribution x, which is a binomial, approximating it to the distribution y, which is a normal. Using the formula, mu is equal np and sigma is equal square root of np multiplied by 1 minus p. Once we've carried out our approximation, then we moved on and we actually estimated each of the probabilities, applying a continuity correction. Here is an exam style question. A drill bit manufacturer claims that 52% of its bits last longer than 40 hours. A random sample of 30 bits is taken and X lasts longer than 40 hours. Part A, find the probability that X is less than 17. Okay, so in our question we have a sample size of 30 and we have a fixed probability of 52%, which is 0.52. So this indicates that X will follow a binomial distribution with sample size 30 and fixed probability 0.52. So what do we want to actually calculate? Well, we want to find the probability that X is less than 17. Now for less than or equal to probabilities, we can use the binomial CD function in our class-based calculator. So what we have to do is rewrite this probability as the probability of X being less than or equal to 16. In order to use the binomial CD function in our class-based calculator. So we have that capital N, the sample size is 30, lowercase x is 16, and P, the fixed probability, is 0.52. So I can input these values into my calculator. I'm going to be using the binomial CD function. So using the binomial CD function gives me that this probability is equal to 0.6277 to 4 decimal places. Okay, let's move on to the next part of the question. A second random sample of 600 drill bits is taken. Part B, using a suitable approximation, find the probability that between 300 and 350 bits last longer than 40 hours. Okay, so let's have a look at part B. This time if we take X, it does follow a binomial distribution, but the sample size changes. It goes from 30 bits to 600 bits. So we've got 600. Our fixed probability P remains the same, it is 0.52. Because the manufacturer claims that 52% of its bits last longer than 40 hours, and over here what we are trying to work out is the probability that between 300 and 350 bits last longer than 40 hours. So we follow the claim of the probability being 52%, hence 0.52 is your fixed probability P within the binomial distribution. It stays the same. Okay, right, now what we want to do is take this and approximate it using a normal approximation. So the x gets transformed into y, which follows a normal distribution with mean mu and variance sigma squared. Okay, so to calculate mu, we have to apply the formula sample size and multiplied by the fixed probability P. And to calculate the standard deviation, we have to apply the formula square root of the sample size multiplied by the fixed probability P multiplied by 1 minus P in bracket. Okay, so let's first of all calculate the mean mu. We have 600 multiplied by 0.52. So if I put this into my calculator, I get 312. The standard deviation is given by square root of NP, which is 312, multiplied by 1 minus my p-value, which is 0.52. So if I put this into my calculator, I get the square root of 149.76. So I've applied a normal approximation. I've taken the discrete binomial distribution and I've approximated it to a continuous normal distribution. That was my suitable approximation. Now the probability that we're trying to calculate is the probability that x is between 300 and 350. So x is more than 300 but less than 350. Ladies and gents, please remember when you go from a discrete distribution to a continuous distribution, you have to apply a continuity correction. So to help explain the continuity correction, I'm going to draw a diagram. So I've got two blocks. The first block is for the 300 and the second block is for the 350. Now x equal 300 is not included, x equal 350 is not included, so we do not shade in the blocks. We have to shade in everything between 300 and 350. So this part over here is what we shade in. Now we can compute the lower and upper bound for each of these numbers. Let's start off with the 300. So we've got 299.5 and we've got 300.5. Over here we've got 349.5 and 350.5. Okay, so we see that the shading starts at 300.5 and it ends at 349.5. So this probability over here, ladies and gents, is approximately the probability that y is more than or equal to 300.5 but is less than or equal to 349.5. Again, this probability represents an area because y follows a normal distribution. So y equal 300.5 and y equal 349.5 contribute to 0 areas. So I can actually exclude the equal signs and the probability will still stay the same. But we want to be consistent with our diagram. So let's just include the equal. Right, so let's draw a bell-shaped curve to represent this area. So here is my bell-shaped curve, ladies and gents. It is centered at the mean 312. 300.5 is to the left-hand side of 312, so it will be somewhere over here. And 349.5 is to the right-hand side, so it will be somewhere over here. This is a rough sketch. So we want the area between these two numbers. That area represents this probability. Okay, so from this diagram we see that the lower limit is 300.5. The upper limit is 349.5. And we also have that the mean mu is equal to 312. The standard deviation sigma is equal to the square root of 149.76. Okay, so to calculate this probability, I'm going to use the normal CD function in my calculator with these values. Okay, so if I use my ClassWiz calculator, I get that this probability is equal to 0.8252. Okay, that there, ladies and gents, completes part B of the question. And that there, ladies and gents, completes this exam style question. If you found this video useful, please don't forget to leave a comment, leave a like, turn on the notification bell so that you receive notifications every time I upload teaching videos. And please don't forget to subscribe to my YouTube channel.